Right, I'm going to take you through a quick experiment that I decided not to show you in person, quite simply because it's really hard to see with the way that I need to set it up. The idea of it is to look at how the colour of the surface of an object affects how quickly it cools down due to the fact that it's giving out radiation. So we're not looking at conduction or convection here. Those will be happening in small amounts, but we're going to try and minimise those as much as possible. We're going to look at how it loses energy due to radiation. So anything that's hot will emit radiation, and the colour should affect how quickly it cools down. So what I'm going to do is I'm going to fill up both cans with water, and I'm going to get them both hot. So they're just hot objects, and they're exactly the same can, exactly the same material, and they're going to go into the same environment. And then I'm going to let them cool down. Ooh, very exciting. Hopefully there should be an obvious difference between the two. We will. Okay, so I have now let them heat up to the same temperature, poured the water out so that they start to cool down in the room, in the environment. I've put cotton wool in the top of both cans. That means that any air which gets hot and would want to rise out of the can can't. So I've stopped convection happening, and I placed them in a cardboard box. That has two benefits. Look at this in the cardboard box. There we go. That's got two benefits. That's got two advantages. It's an insulator, the cardboard box, so it should stop conduction from the cans happening too much. So if I've stopped convection because I've got cotton wool in the top and I've stopped conduction underneath, they should only be losing energy due to radiation. So they're both in the same environment inside this box. That stops them absorbing any radiation, so that's going to stop the other effects that we know about things absorbing more radiation than each other. So they're not absorbing any radiation, they're just losing heat due to radiation. Now, they both started at about 80 degrees, and we'll have a look at what temperature they are now. I'll see if I can film this on selfie, which probably won't work. Okay, couldn't get selfie working, but let's do it this way. See, if I point that at the black can there, we're at 33, 32 degrees, that sort of number here. Point it at the white can here, 37 degrees. So the white can is considerably warmer. They both started at the same temperature, about 80 degrees, and the white can is cooling down less quickly, which means that the white can is emitting less energy due to radiation. So black objects, hopefully this is convincing, black objects are the better emitters. They're better at emitting radiation. Now that means they'll cool down more quickly in the same environment, as you can see here. That's quite an important thing to know. Okay, I think that is everything you need to know about and see. Are you convinced? Hopefully you are. Okay.